Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Don't Call Me Shirley by Cassini. And I believe that's a reference to Naked Gun. I've never actually really watched the whole Naked Gun movie. And this was the original one, I believe, with I don't remember his name. I remember Leslie was part of his name because I remember it being a female like name, but it was to a male actor. Um, but I believe the thing was that I believe the joke was something along the lines of one person was saying, "Surely you jest," or something like that, and or "Surely you're joking," or something like that. And the main character, I believe it, I don't remember the actor's name or the character's name, but he says, "I'm not joking, and don't call me Shirley." And I think that's what the reference is to what the title is called. I'm not sure if that relates to the puzzle at all, but it's interesting reference there. Anyways, we have the rules where normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have German whispers, where adjacent digits on a green line differ by at least 5. So, for example, if this were, say, a 3, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are specifically 8 and 9. And I will be calling them Whisper 5 lines because a setter came up with that naming convention, and I thought it made a lot of sense to make it because it's very easily extensible. We have Renband lines where digits on a magenta line form a non-repeating consecutive set in any order. 2, 3, 4, 5, 6, 7, 8. So these are size 8 Renbands. So this Renband line could be either, well, specifically, it's either 1 through 8 or 2 through 9. Because it's 8 in length and you cannot have repeats on a Renband line, and they must form a set of consecutive non-repeating digits. And if you had like 1 through 7 plus 9, that doesn't work because they don't form a set of consecutive digits. So that's an example of how Renband lines work. We have killer cages where digits in a cage do not repeat and sum to the small number in the top left of that cage. So this could be an example of, say, 8, 7, and 2. And that would be valid because these 3 digits add up to 17, which is the number in the top left corner of that cage. And that's an example of how killer cages work. We have region sum lines, where box borders divide blue lines into segments, and each segment sums to the same total. Different lines may have different totals. So that means the sum of these 2 digits is equal to the same as the sum of these 3 digits, which is equal to the same as the sum of these 2 digits, which is equal to the same as the sum of this digit. Because the box borders divide that line into segments, that's why those have to equal those same sums. And that's an example of how region sum lines work. We have crop key dots where digits either side of a white dot are consecutive, and digits either side of a black dot are in a 1-to-2 ratio. That is, one is double the other. So if this were a 3, this would have to be 2 or 4 to be consecutive with it because there's a white dot between them. If this were, say, 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio that's between them because there's a black dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. let's learn how to Sudoku. Okay. Well, where I think I will start is this central box. So on the Whisper 5 line, this digit is next to 4 other unique digits on a Whisper 5 line. The only digits which can be next to 4 unique digits on a Whisper 5 line are 1, which can be next to 6, 7, 8, 9, or 9, which can be next to 1, 2, 3, or 4. Well, this digit and this digit is equal to the sum of 3 unique digits. That's going to be at minimum 1, 2, and 3, which means this digit must be 6, 7, 8, or 9, and so must this one. And in addition, we know these are next to black Kropke dots, so they are in a 1 to 2 ratio with another digit. 7 and 9 cannot be in a 1 to 2 ratio with another digit, because if you have 7 or 9, you get 3.5 and 4.5. If you double 7 and 9, you get 14 or 18, none of which are digits. So this can only be 6, 8 here as possibilities, because they are the sum of 3 unique digits, right? Or exact. So this has to be 6 and 8. And those are only 5 or more away from 1. So therefore, the other digits that are next to it on the Whisper 5 line must be 7 and 9, which must be consecutive with only 6 and 8 here. Interesting. So these equal the, so this has to be the 3 digits here and the 3 digits here have to be either 1, 2, 5, 1, 2, 1, 2, 1, 3, 4, or 1, 2, 3. So this is guaranteed to be 1 through 5 with a guaranteed 1 in one of those cells in that box. 6 and 8 is in a 1 to 2 ratio with 3 or 4. So this is 3 or 4. This is 3 or 4. Again, so these add up to 6 or 8. So that means you could have 1 through 7 here. And 1 through 7 here. Same with these. So 1 cannot be any of these cells here. Therefore, 7 can't be here, 7 can't be here, 7 can't be here, and 7 can't be here, because if it were 7 here, that would require 1 to be there. Also, we have a 6-8 pair in column 4 and column 6, which eliminates 6 in the rest of the column, or 6 and 8 in the rest of the column. So next to a black Kropke dot, the only digits, so we already showed 7 and 9 cannot be next to a black Kropke dot. The other digit which cannot be next to a black Kropke dot is a 5 in normal Sudoku. Because if you have 5, you get 2.5, and if you double 5, you get 10, neither of which are digits. And since this cannot be 6 or 8 because of the 6-8 pair in the column, this has to be 1, 2, 3, or 4 here. 1 can be next to 2. 2 can be next to 1 or 4, but this can't be 1 because of 1 in the column, so this would be 4 if that's the case. 3 can be next to 6, and 4 can be next to 2 or 8 as possibilities. Okay. Okay. Remaining digits of the central box are 2 through 5. Does that help us any? Let's color these cells. We're going to make this red and this dark. That means this must be not dark for this cell, so this must be red. This can't be red, so that's dark there. So red has to be one of these 3 cells there. Remaining, so 3 cell cages adding up to 24 and 23 are unique. They can only have one set of digits that add up, so one set of unique digits adding up to them. 24 must be 7, 8, 9, and 23 must be 6, 8, 9 to add up to 24 and 23 respectively. Okay. Um, okay. Again, these Renban lines are 8 in length. 1, 2, 3, 4, 5, 6, 7, 8. So they have to be either 1 through 8 or 2 through 9. Um, hmm. Um, hmm. Um, hmm. Where do we go to next? These 3 digits can never be in these cells here. This digit could be here, here, or here. Remaining digits in... where is 7 in row 1? Can't be here because of this is 6, 8, 9 as a triplet adding up to 23, and this adds up to a single digit. Can't be next to the black Kropke dot. Can't be here because of the 7, 8, 9 triplet because they must add up 24 here. So 7 has to be here in row 1. That eliminates 7 from being here, so this is 9, which can only be consecutive with 8. So therefore the reds have to be 8. The darks have to be 6. So this is 6, which is consecutive with 7 there. 8, so 6 is the sum of 3 digits adding up to 6. It has to be 1, 2, and 3 here. That eliminates 1, 2, 3 in the rest of the box. Well, that doesn't help us much. These add up to 6 also. It could be 1, 5 or 2, 4 here. Same with this. This is 1, 5 or 2, 4. This adds up to 8. So there's no 4 available here. There's no 4 available here. This can't be 2 and 6 adding up to 8. So it's either 1, 7 or it's 3, 5 here. This can't be 1, 7 because of the 7 in the box. So this is 3, 5 as a pair here, which eliminates 3 and 5. 8 is in 1 to 2 ratio with 4, and 6 is in 1 to 2 ratio with 3. So this can't be 4 anymore, which means this can't be 2. 4 eliminates 4 as a possibility here. 3 eliminates 3 here. 4 eliminates 4 there. 3 also eliminates 3 here, which means this can't be 5. This can't be 6, which means that can't be 2. To add up to 8. This can't be 3 and 6 as a pair, so it's either 1, 2, 2, 4, or 4, 8. We don't know which. Okay. 3 eliminates 3 here. Hmm. Where is 9 in row 1? Can't be here because of the 7, 8, 9 triplet in the box. Can't be here because of the region sum line and the black Kropke dot, so 9 has to be there. We could have an 8 here, though, so we don't know 8 is necessarily there. Remaining digits of column 6 have to be 1 through 5. This cannot be 3, 5 as a pair. Because of the 3, 5 pair in the box. We have a 1, 2, 4 triplet in column 6, which eliminates 1, 2, and 4 in the rest of the column. So no 1, 2, 4 here, no 1, 2, 4 here. And therefore, this cannot be 1 and 2, because if this is 1, it can't be 2 and 4. If this is 1 and 2 or 2 and 4, that would eliminate 2 possibilities of the 3 that are here for these 2 cells, which means these cells would have to contain a duplicate. So this must then be 4 and 8, which means this can't be 8 here. It's a 6, 9 pair, which eliminates 6 and 9 in the rest of the box. So this can't be 6, it's 8. This can't be 4 because of the 4 in the box, so this is a 1, 2 pair, which eliminates 1 and 2 in the rest of the column. So this can't be 1 or 2, it's 4. 4 and 2 add up to 6, so this is 2 there. That eliminates 2 in the rest of the column. We have a 3, 5 pair in the central box, which eliminates 3, 5 in the rest of the box. So this can't be 5, it's 4. This can't be 3, 4, 5, it's 2. 2 eliminates 2 here. Remaining digit in this upper central box has to be a 9 because of the 1, 2 pair and the 3, 5 pair in the box. 8 and 9 eliminate 8 and 9 here, so it's 7, which means this can't be 7 here. It's 8 and 9. Well, on this Renban line, it's either 1 through 8 or 2 through 9, which means we have to have an 8 somewhere. This cannot be 8 because of 8 in the box. These can't be 8 because of the 7, 8, 9 triplet in the box. Where is the 8 then? It has to be here. But that means there's no access to a 9. So then this Renban has to be 1 through 8 here. And this Renban is guaranteed to be 2 through 9 here, because we have a 9 on that Renban. Okay, remaining digits here. We can't have... So remaining digits in row 1 are 1, 2, 3, and 5. This can't be 3 because of 3 in the column. Remaining digits in column 8, 5 have to be 6 and 7. Remaining digits in column 4 must be 1, 3, 5, and 9. But 1 cannot be on this Renban because it's only 2 through 9, and we already have a 9 on this Renban. So this is 3 or 5. We have a 3, 5 pair in column 4, which eliminates 3 and 5 in the rest of the column. So this has to be 1, 9 as a pair. Where is 8 on this Renban? We have to have 1 because the digits must be 2 through 9. 8 can't be here because of the region sum line adding up to 8 and the 8 in the row. This can't be 8 because of 8 in the box, so 8 has to be one of these digits. Cannot be here because of 8 in the row here, so 8 is guaranteed to be here. Where is 4 on this Renban? Because it must be the digits 2 through 9. 4 can't be here because 4 in the box, can't be here because 4 in the box, can't be these 2 cells because of 4 in the column and 4 in the row. So 4 has to be there. So this 17 cage cannot contain 4 and cannot contain 8. We need a 6 on this Renban for the digits 1 through 8, and 6 can't be here. This can't be 6 because it must add up to 6 on the region sum line. And these can't be 6 because of 6 in the box. So 6 can't be here, 6 can't be here. 6 then has to be there. Okay. Remaining digits on the Renban line. This could be 1 through 5. That's fine. This is also 1 through 5 here. We have a guaranteed 1 through 5 here. This can't be 4, though, because of 4 in the column. This can't be 4 because of 4 in the column. If this adds up to 8 with 1, 3, and 4, the 4 has to be here. So if this were 1, 3, and 4, this cannot ever be 3. Okay. To add up to 17 without 4 and 8, you could have 1, 7, 9. We don't need this red and dark anymore. Maybe we should figure out the 3, 5 pairs. We'll make this blue and this green. So since this is blue, this can't be blue. That's green and blue there, which means this can't be blue. That's green there, which leaves that as blue. Okay. Blue can be one of these 3 digits on the Renban line. That's not too helpful. Okay, let's do the 17 cage again. So 179 is a possibility. 269, no 278, because we can't have an 8 there. 359, no 8, so no 368, no 377. So this is either then 179, 2 with 69, 359. Okay, well, that's pretty broad, so that's not that helpful. Where is 8 in row 5? Can't be here because of 8's in the boxes. Can't be here because it adds up to 8 on the region sum line. Can't be here because of 8 in the column. So 8 has to be here, which means this cannot be 8 here. Where is 8 then on this Renban? It has to be here. That was good. 8 eliminates 8 here, so this is 9, and that's 8. Where is 8 remaining in... Well, we have 8 8s. That means we know where the last 8 has to be. It has to be here. So that's 8, which means these 2 digits add up to 18 minus 8, which is 10. And we don't have 1, 2, 3 available, so that leaves this as a 4, 6 pair. And this can't be 6 because of 6 in the column. So that's 4 here. This is 6 here, which eliminates 6 here. So it's 7 and 6 there. That means we need a 6 in this one of these cells here on the cage, because we can't have a 6 available in the rest of the row because of 6's in the boxes. So 6 has to be here. That means the other 2 digits must add up to 17 minus 6, which is 11. We can't have 4, 7 available. We don't have 3, 8 available. We don't have 5, 6 available. So this has to be 6, 9, and 2 to add up to 17. So it's 2 here. This is 6, 9, 6, 9. This can't be 2. We have a 1, 3, 6, 9 pair eliminates 6 and 9 in the rest of the row. This can't be 9. That makes this 1, which makes that 9. 1 eliminates 1 here, so it's 3, which eliminates 3 here, so it's 1, which eliminates 1 here, so it's 2. 1 eliminates 1 here, so this must be 2, and 4, adding up to 6. That eliminates 4 in the rest of the Renban line. Where is the 4 in this upper right-hand box? It can only be here. Which means this cannot be 1, 3, and 4 adding up to 8 here, because 4 can't be in any of these spots on the region sum line. So this is 1, 2, 5 as a triplet, which eliminates 1, 2, 5 in the rest of the box. So this can't be 1, 2, or 5. It's 3. And this has to be a 4, 7 pair, but this can't be 4 because of 4 in the column. So this is 7, which makes that 4. 7 means this can't be 7 here. This can't be 3 because of 3 in the column. So this is a 6 and 2 adding up to 8. 6 eliminates 6 here, so it's 9 and 6, which eliminates 6 here, so that's 9 and 6. 3 means the blue 3, 5 must be 5, and the green 3, 5 must be 3. That eliminates 3 in the rest of the Renban line. This can't be 3 because of 3 in the column. Where is the 3 in this upper right-hand box? It must be there. 5 has to be on the Renban line, so it's one of these 2 digits here, which means this cannot be 5 here. 2 eliminates 2 here on the Renban line. This can't be 2, and this can't be 2 because of 2 on the Renban line, or 2 in the columns. So therefore, where's the 2? It has to be here. This 5 eliminates 5 here, so that's 1, which makes that 5. 1 eliminates 1 here, so that's 2 and 1 here. 1 eliminates 1 and 2 eliminate 1 and 2 here, so it's 5. This can't be 5 anymore. It's 1, which makes this a 2. So the rest, I think, is just normal Sudoku. Whereas the 1 in row 9 cannot be, these are filled out. 1 can't be here because of 1 in the column, so this is 1, which leaves that as a 3. We have, where's the 1 in column 3? The rest are filled out. It has to be here. That gives us 8 ones. We know where the last one has to be. It has to be there. 2s, we should have 9 2s. We do. 3s, we have 8 3s, so we know where the last 3 has to be. It has to be there. 4s. 1, 2, 3, 4, 5, 6. We have all the 4s. 5. 5 in column 2 cannot be here because of 5 in the row, so 5 has to be there, which leaves this as a 7. We don't have as much information about 5s, though. Oh, we do. Okay, in this right central box, 5 can't be here because of 5 in the column. 5 can't be here because of 5 in the row. So 5 has to be there. That means in row 7, 5... Actually, yeah, row 7, 5 cannot be here, so 5 has to be there. We have 8 5s. We know where the last 5 has to be. It has to be there. 6s. We have 8 6s. We know where the last 6 has to be. It's there. 7s. In column 1, 7 can't be here because of 7 in the box, so 7 is there. In row 7, 7 has to be there. In column 9, 7 can't be here because of 7 in the row, so 7 is there. I think that's all 9 7s, right? 1, 2, 3, 4, 5, 6, yep. 8s. We have all 9 8s set, and then the rest must be all 9s because we've done every other digit. And that's how you solve this puzzle. Fairly, well, not straightforward, but the logic isn't too hard here. Yeah, I'm not sure anything else to really say about it. These are actually common things that you will find, like 3 unique digits adding up to a single digit in normal Sudoku. The black Kropke dots, definitely. Cages adding up, or 3 digits adding up to 23 and 24. Renban lines throughout. So, yeah, and these are all very common techniques, which you will run into if you do a lot of variant Sudoku puzzles. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.